Hello and welcome. In this video, we'll be talking about how to add fractions and subtract fractions with the same denominator. This is on page 14 in your Alex notes. Whenever we're working with numbers or fractions, it's always important to remember that there's a referent. In other words, there's something we're referring to. When I'm saying 2/5 or 1/5, 2/5 of what or 1/5 of what? It's really important that we consider this because, again, in math, a lot of times we're only adding things together that have the same size and same shape. So in this particular example, if we look at number 1, they don't give me a reference. In other words, they don't tell me what one whole looks like. So what I'm going to do is I'm going to draw out what I would consider to be one whole. Now, my picture is a rectangle. I could have used a circle. I could have used a square. I'm just using a rectangle because I feel comfortable dividing a rectangle into pieces. So I'm considering this to be my one whole. So if I look at 2/5 and 1/5, the first question I have to ask is, are 2/5 and 1/5, can I add those pieces together? Are they like the same size and shape? Well, if I draw out 2/5 and 1/5, again, if this is my whole, this is my one whole, then 2/5, if I shaded it in, okay, those are supposed to be 5 equal sized pieces. And so if I shaded 2/5 in, that would be 2 of those pieces. 1/5, so this would be 2/5. 1/5 would be 1 of those pieces shaded in. And so it definitely is fair for me to add these two things together because they are the same size and same shape. Okay? So when I'm adding fractions together with the same denominator, well, if they're the same denominator, what that means is I'm going to have same size and same shaped pieces. So if I add those together, well, how many pieces do I now have? Well, I now have 3. And I'm always comparing to one whole. So if I look at one whole, how many groups has that one whole been broken up into, or how many pieces does it have? Well, in this case, it has 5 equal sized pieces. So what I'm left with is 3/5. Okay, so notice the denominator stays the same. Okay, because again, we're comparing to one whole. That's why the denominator stays the same. One whole is cut into 5 equal sized pieces, or it's divided into 5 equal sized groups. And out of those 5 equal sized groups, we had 2 of them here and another 1, so that gives us 3. Okay, so the 3 comes from just adding the tops. So if we go on to number 2, well, I want you guys to try this one on your own. Pause the video and then restart it when you're ready. Okay, of course, again, in this case, I would want to draw my referent. So my referent, again, I'm assuming that one whole looks like this. And without even drawing it out, I can see that since they're both over 16, that we're talking about same-sized pieces. So I'm talking about adding 7 pieces with 3 pieces, and each one of those are going to be the same size and shape. So what I can say then is I have 10 pieces, and each one of those pieces is exactly 1/16 of the entire whole. Okay, so my bottom stays the same because, again, one whole in this case is divided into 16 equal-sized groups, or it's cut into 16 equal-sized pieces. Okay, let's look at number 3. Okay, this time we're subtracting, but again, it's the same story. So our denominators are the same. What that means, again, is we're taking 6 pieces and we're subtracting out 2 equal size pieces with the 6. So that means we certainly can subtract them. Makes sense to do so because the 6 and the 2 represent pieces of the same size and shape. So what I would end up with is 4 pieces. And then my whole is cut into 10. So that doesn't change. I still have 4 pieces out of a whole that's cut into 10 equal size pieces. And one thing I forgot to do in the last problem was to reduce this a little bit. So we're going to go back and do that one in a second. But this guy I see I can reduce. If I divide both top and bottom by 2, I would end up with 2/5 as an answer. And over here, if I divided top and bottom by 2, I would end up with 5/8 as an answer. Okay, I want you guys to try number 4. Pause the video and then restart it after you've given it a try. Okay, so you should have gotten an answer of 6/20 initially. Again, the denominator doesn't change. We're just subtracting the numerators. And then if I simplify this, divide top and bottom by 2, we should end up with 3/10.